Okay, so for a ground crack or ground shattering effect, let's start with a grid. So I just in here, let's add a geo, and let's name it ground shattering. Let's get inside, add a grid, which will be our ground. So this is not like a huge ground. If you see, it's 5 by 5, so we can make it larger, like 20 meter by 20 meter, and maybe like much more details, 100 by 100. So that's our ground. So how do we want to crack this? You can tell it, you can guide it. By the way, as I said previously, I would like, it's a matter of preference. I would like to have my parameters hidden and loaded whenever I press P. So I have a nice node graph in front of me. So we can bring a curve, so like draw a curve. So I just drop it. So if I want to draw a curve, if you go here, like tap this, you see that you can draw a curve here on this, but I want to draw a curve on another plane. So I just press P and I say that projection going to be on Z and X, okay, and then I might go spacebar 2, and then I will start from top, like draw my crack the way I would like. So that's my line. So if you look at the points on this line, if I just make this line visible, spacebar 1, the points on this line are very much just few points. So we can have more points because those points are data, are the ones that help me to project some data for the cracking effect. So I just resample my curve. So when I resample my curve, I've got plenty of points on it, so which I can use for my simulation. So to make this animated, search for a node that is called carve. This node is very useful for not just this curve, but everything that you want this to be carved out or in. Look at this one. Like, so at the beginning, we want this to be 0. Actually, I would like this to start from top to down, not from down to top. So I can reverse my curve. You don't need to do it if you would have drawn this like from the other side. So let's say, yeah, now you see that like it starts from here. So let's go 0 at the frame 1. So you can Alt and click here. I don't know, in 2 seconds or maybe 1 second. No, 35 frames. We go 0, which, so that's like, let's play that in real time. That's not bad. Okay, I like that. So that's my curve. Now I have a grid. So let's color this curve, because color information, guys, color information can be translated into other data very fast and easy. So we use color information for a lot of simulation. So I assign white to this. I might assign like black to this. So if so this one's black, this one's white. So let's transfer the attributes from white to black. So what I'm looking for is at transfer. So it's attribute transfer. So this one is geometry to transfer attribute to, which is the ground. Geometry to attribute transfer from, which is the white. You see that the entire white of this has been transferred. But I can be a little bit more kind of refined. So blend a bit. So this is the area that like kind of pops out, right? So when it pops out, what would happen? So of course it moves up. So I'm going to create a rest attribute. I have to explain to you what it is. So let's say you have a point in space. So this is a point, because, and it has some x, y, z. Let's assume that it's in 0, 0, 0. It's in like in the center. So when I go through like a lot of nodes, a lot of procedures, like let's say, I don't know, node 1, let's call it operation 2, operation 1, operation 2. Each node is an operation, right? I do some stuff on this node, and this point goes somewhere else. So let's say it comes here, x, y, z. This point might be like a point on the face of your creature. It might be like a point in the cracked surface of the, it could be anything. It could go like into 1, 6, 7, and then like move to -7, I don't know, 11, 8. So it moves around, right, as we apply operations. So sometimes you just want to say that, okay, I applied operations on this one, but I always want to know where this point was at the beginning of my story. So we call this position, this one, as a rest position. And we save it as a node into an operation. So we call it operation or rest node, which says that wherever you are, whatever happens, this is where the initial like kind of condition of this point has been. So what would this apply to my world? What does it mean? It means that, like, let's say when the cracking happens, so let's say this one, when the cracking happens and the surface cracks, this part comes up, right? It just moves up. So it actually transforms up. Let's say that much transform up. And then it just like kind of becomes noisy. Let's add some noise, attribute noise. You can add noise to not color, but position of the points. So you see that these points have a position in space. So you see that like the first noise was CD or color diffusion or color data, whatever you want to call it. So, but I would say that I want to apply noise to points. And the points that I want to apply noise to, actually, I should delete that color. Let's say this would be like a Perlin noise, which I like because it gives me this kind of like very big element size. So, and maybe like a little bit more offsetted, a little bit more amplitude, whatever, I don't know. So, but whatever it is, this ground from here moves up, turns into something else, but just part of it, right? Not all of it, but part of it, that part. So I can create a rest node here in middle, say that rest position. So this is the rest position of the ground, right? So now, before that, if I middle click here, oh, by the way, I might lose things, so it's time to just say, hey, we want to create a new project. let's go on our desktop. We have this project X for our Houdini projects. I call this ground shatter version 1. Actually, if you remember, after naming convention, I explained, talked about, so ground shatter. So it's good to mention where we are. So maybe simulation version 1. So now what I do is that, so rest position is here. Maybe I just grab this color and take it after rest position. So I have this. So before rest position, I have a grid with some points. If I middle click on it, after rest position, I have the same grid with some points with a rest attribute added to it, which is very interesting. So now we can just say that we use a point VOP or point VOP. What is that? It's a VEX operation, but it's a visual VEX operation. So don't be panicked by this kind of VEX procedures. They are very easy to use. It's their visual. If we get inside, there's an entry and there's an input and output. So if I just connect from P to P, means that nothing happens. So a point is where it was. But I can do more. I can just say that, hey, do you remember rest position? If I just search for bind, and in the bind, I search for a character called rest, right? I say that, do you remember rest position? I would like to mix it with my current position. So I have a rest position, I have current position, and I wanted to blend them together. But how I want to blend them together based on the color, right? So then if we go up, so this should come from points from here, rest position from here, and output here. So we have to make sure our rest position is a vector attribute. Okay. So that means that, what is a vector attribute? It has 3. It's an x, y, z. It's not just one attribute. So now I can combine these 2 attributes together. So so if you see that, like, kind of when let's go back to what we have done. We'll just say that, hey, grab the rest position, grab the changed position, and multiply that together, and just export it out as basically, so based on the color, right? So not a very complicated thing. So now I can delete that color attribute. So I can say @delete, attribute delete. So I can delete here. I can say that delete color. So we only say this. I can do a lot better here in terms of transformation and everything. Here is transformation. Here is the attribute transfer, softening, and here is the noise, amplitude maybe. Yeah, like this makes more sense than the previous one. So now we have something as a base, like it just passes through, like it's a bump on the surface that cracks the surface. Let's start cracking our surface. So I can export this grid. So I just search for a null. You know, this null doesn't do anything. We just use it as indicator every now and then. So I just say grid go out. You can ignore that, or you can create it. So let's make a surface out of it. Poly extrude. Like how thick we wanted that thick. Let's look at your surface. Very important is just to see that at the moment it's like hollow, but we want it would be like a proper filled in. So make sure that the back is also created. What you do is just like, as you remember, RBD material fracture is what we use for fracturing this surface. What is RBD material fracture? It fractures the surface, pre-fractures the surface. So let's look at it. I press W on my keyboard. It fractures. Let me just go and delete this or disable this second one. So you just see one. So it fractures into 5 pieces, and then each one of those 5 fractures into, let's say, another 5 pieces. So that's how it works, right? But I want a more art-directed fracturing alongside that curve. So what I can do, I say that, you know what, I have some points. So let's grab these points from this color. Do you remember this color here underneath? Let's go a little bit further forward. Yeah, you see there's some colors here. You just say that, just output this color. Out color. We don't want this to be animated, so I just can say that time shift. Time shift is a node for retiming and also for, let me just go where it all is there, and for freezing too. Like if I just hold Control Shift and click, or just right click and say delete channel or delete parameters. Delete channel, yeah. So the keyframes are removed. So I can scatter some points. So I'm scattering some points here. You see that white and black. Actually, I can scatter some points and based on some density attributes. So you see that it's white and black, but I don't want the black ones, right? I just want the whites. So I can say density attribute, and that density comes from color, right? We don't want that many points, so this points here is enough. But also we want some points from the grid anyway. So this is the points from the crack. So let me just dive this in. Let's fit these points into our extra Voronoi points here. And I just press, here I go, press W, go to the beginning. You see nothing has happened yet. I can tell that I have extra Voronoi points in the first cracking layer. You see it's thinking, and also in the second cracking layer it's thinking more again. But what you get is that this beautiful structure, that the area that the cracking must happen, there's much more thing going on. Actually, I don't like this, so I just delete second part. I maybe art direct this a bit, 6 maybe. Maybe rotate this noise a little bit. Yeah, that's better. Maybe add more shatter points, maybe 8. That's even better. maybe I bring some points from the surface too. Actually, I can scatter few points on this little grid here. Let's say the grid has points, not that many, just maybe like that much. And I don't want this to be relaxed. Actually, the scattering point of here also, look at how relaxed this point has been distributed. It looks nice, but it's not that chaos I'm looking for. So I just turn off the relaxed iteration for those ones too for myself. Maybe those ones I bring them a little bit down. So that's for the surface. Maybe a little bit more. And then we merge these together. Merge this one and this one together. So that would be the source of the points on the surface. Now we have cracked the surface based on that. Maybe less point here. Maybe more point here. Oh, yeah. See? I finally achieved what I was looking for. So that's one level of cracking. I can add another level. But the next level, you don't want like 5 in each. You can go for like 3 or 4. So this big crack in the middle is a bit disturbing. Maybe I'll go for 8. I should use the input points for the first one too. Okay, so that's 8, that one 8, maybe 5, the second iteration 5. So you see guys, I spent a good amount of time for my initial cracking. Then because after that, I cannot direct. I can achieve like a very nice surface cracking. So maybe that, like if you just exploded view, like exploded view, RBD exploded view, so you can see the exploded view, RBD exploded view, drop it here. You can see how these ones are cut. If I press W again, so that's how they cut. I really hate this, like laser cut edges. That's fast because it's based on an algorithm I talked about before, which is called Voronoi fracture. But we can add some chipping and some edge details. So let's add some edge details. So let me just save it here. Oh, we didn't save it. So ground. We created the project, but I forgot to just save it. I should have saved it properly, but anyway. So let's carry on and add some edge details. I have to wait because that takes time. Okay, nice. So what we did, again, let me review that. We created our point VOP, which is this, well, we'll get there. So with this surface as a base deformer, let's say deformer. Then we created some points in the space, some points scatter some points here on the area that we want to crack, scatter some points around it, combine that together, and art directed our cracking that to follow that spacing. things that like this is because of that edge detail that you just saw, like the edge detail added. So you just have to play around until you don't get like these artifacts. So because we don't have time, so I just like leave that to you. So you can add edge detail, you can add some chipping. Chipping is nice too. Okay, so if you look at the exploded view, look, you see these little things around. These are very nice. So these are actually the chipping. So you can add even more, like you can add some interior detail and so on and so forth. But to save time, I just leave with what I got. So now what I do is that I just like want to say that, okay, so I'm going to create a sort of a fake shattering, not a simulated one. And then I build the simulation on top of that. So what I do, I don't need this one. So we use a node called point deform. As I said, that point deform, this node here. So the point deform, what it does, it has 3 inputs: deformed point, lattice, rest point, and mesh to deform. Definitely we want to deform this mesh, right? And then our rest point comes from, let's say, this color is sort of a rest point for us. And our deformer is basically this one. So what would happen is that I get this, like when we go through, we get this like kind of cracking, but it doesn't work now. It's okay. So because you have to just go to attributes and okay. So the issue here that I forgot is that, so it does its job, which means that it has deformed every single point. So if you see that, like every single point of this ground is deformed. However, so look at this cracking. I would like you, before I carry on, just going to save this, I would like to introduce another very important topic, which is called packing. So let's assume that you've got a very complex mesh, like this mesh here has like lots and lots of points in it. Let's say this mesh has 100 points on it. 100 points. That's a lot of data, right? But there's one point in the center of it that we can say that, you know what, ignore all of these points. Represent this mesh with one single point. We call it packing, that single point. So your mesh information will be, so you don't have access to the, if you want to deform each one of these points on the surface, you have to do it on a actual mesh, right? But if you just want this mesh to just rotate or move around, so why not just packing it? So let's look at here. So let's say, let me just bring a test object. This rubber toy. Look at this rubber toy. So if I middle click, it says that it has 12,000 points, right? And if I click on the information here, so it stays there. How much of disk space it has occupied? It has occupied 1.8 megabyte of your memory. So you might just say that, oh, why should I care about this? Because a simulation is big, like there's plenty of information there. So if I pack this, right, what I see is that 1 point, suddenly it becomes from 12,000 points to 1 point. And the disk space that it occupies is just 2 kilobytes, like about, I don't know, 100 times less, maybe? Yeah, something like that. Like about 80 times less disk space. So if I want to, like, let's say, if I want to do like a very stupid thing, let's say I have a sphere here, a giant sphere in the space. So if you plan to do like those kind of like crazy simulations in Maya, let's say I want like to have hundreds of this falling on the ground on top of each other, right? That's many of this, right? Let's make this smaller a bit. Okay, so I have got a sphere. I can copy 2 points. This one, this is the geometry to copy. This is the the points. So actually, this is what I want. So if you see that I have copied hundreds of this, right? But I want this to be inside that as well. So I just do an ISO offset. So this will turn into like a ISO surface. So you see that. Let's see. Is that an ISO surface? No. Let's go fog. It becomes like a fog, but then scatter points like inside that fog. So I have scattered 1,000 points, but we want 100 points. So you see that 100 points everywhere. Now I distribute this around that 100 points, right? You can be more creative, like say that attribute randomness or attribute randomize. So you can say that, let's say you have to create an attribute about rotation first, which we'll call normal. So let's create that attribute first. Attribute create. So let me just explain to you the issue. The issue is that all of them are directed in the same angle. You see that one? So what is rotation of a point? So you have these points. This point has, if I middle click on it, only have a position in the space, but they can have attribute name n, which is normal, which is the orientation. Now they have orientation and position, and now I can randomize orientation. So now what would you see is that 36. Oh. How we can I'm getting old. So the distribution should be like normal between still not doing the job for me. Okay, so here, like, let me just go back to what I forgot. Is here, like, when I create an attribute, the attribute that I created here. So here, So let's say I packed it. It's a point in the space. And this point has a position. This position in the space is not one number in it. It's actually 3 numbers, x, y, z. And rotation, which is normal as well, has 3 numbers in it. Rotation, let's say, in x direction, rotation in y direction, and z direction, right? So if it only had one attribute, it was a float attribute. But as it has 3 attributes, it's a vector attribute, vector. So I say that I'm creating normal map, which is a vector. So if I middle click on it, you see that I should have realized it here. So because the float attribute is green, but vector attribute is purple. Class is point, and it's vector. So now, what just happened? Yeah. Now I have like n, which is vector, and point, which is a float. Now when I randomize, actually even constant value would do the job. No, constant, uniform, continuous, like continuously rotate all of them together, but like you can do normal, like each one of them rotating in a different angle. So I randomized their kind of rotation. I can attribute create p scale, which is like their size, p scale, but size is float now, guys. So size is something that kind of is not vector. It has the size. So let's say size or scale is like just one number, like scale, let's say s. It's either big or small. It doesn't have direction. So it's not vector. So the default value could be like 1. And value would be 1. So all of them are 1 scale. But I can, same way, randomize that too. So the p scale randomization would be, so search for p scale and then randomize it between. So here you see that it's randomized between 0 and 1, but I can randomize it between half and maybe 2. So, oh no, 2 is too much, like 1.5. So you see that I have suddenly I've got loads of objects. So the main point of discussion was this packing, right? I just wanted to talk about this packing. If I middle click here, you see that I have 100 points, and they occupy about 380 kilobytes of memory. But if I turn off this packing, I have 280,000 points. And they occupy about 200 megabytes of memory, like close to. So that's a lot of computation. So packing is so important everywhere. So when I create an RBD simulation, so I can solve an RBD solver here, RBD bullet solver here, and drop it here, and I say that there is a ground as well, and run this simulation. So if I click here, actually, so when I run this simulation, you see that 100 objects are, wow, that's a fairly fast simulation, like for this amount of little details. How this is possible? How this could be so fast? It's possible because of packing. Okay, I said all of this to get to this point that here if I pack each one of these little pieces, so I have, let's say, I have many points here, but each one of these ones could be assembled. Assemble is this like a pack node, but for like a lot of objects. So I would say that I want to create pack primitives, and I want to yeah, just leave the naming as is. Just then I would what I get is that now I've got 654 points. Now this point deform only deforms those points and not everything. So then you get this like interesting results that like the ground cracks. If I play that, it just like cracks and goes forward. It's not simulation, it's just like, it's just point deformation. So we don't have simulation yet, because we can build the simulation on top of this. So what we can do is that, oh, by the way, the only big issue is that it just pops like boop, suddenly like that. So it's not like, so that's manageable. You can blend shape. We know blend shape for face animation and things, but it basically is blending like a previous point position to the next point position. So you want to blend this with before when it was assembled, right? So you can animate that maybe here when it pops out. So you want this just to just like, if you go like softly, if I alt click, that's frame 1. Actually, it must be 0 here. Alt click here and go to the beginning, alt click. So it just like rises up very nicely to the end. So that one we address that. So now you can use this. First of all, this one can carry a lot of dust information, guys. So this, look at each one of these points, right? There's plenty of points here, right? Look at this point, for example. This point moves from here to here. So then there will be some velocity to it. Let me unpack everything so you guys see every point in this geometry. So look at these points. They move. Many of them are moving. Some of them are not moving. Some of them do move. How do you know which one moves, which one doesn't, and how much they move? You can compute that with a node called trail. And in trail, you can compute something we call velocity. So if I go here and I say that compute velocity, so it just thinks a bit, and if I play and get to a point that things change, so if I turn on, look at this display point trails. If I turn that on, some points like these ones here, they don't have any velocity, but these ones indicated with this like display thing, they have a lot of velocities, right? So you can use these velocities to emit some dust, let's say. There is a very handy node called debris source that we use quite often, and I can attach to it, and I say that, hey, this debris source is, as you can see, it just like scatters a lot of points everywhere, heaps of points everywhere. But some of these points move more. So this one says, okay, diagnose them, find them. Find those ones that move fast. So then those ones could be the source of, if I come here, at this point I think, guys, it would be nice to do some sort of a disk cache. So I would do it for, let's say, I'm looking for, let's say, 50 frames, not much. Yep, and I would just press, and at this point, before here, I do a file cache. What is caching? As you work through, when you have some information that you are kind of like happy with, it's good that you just save it on the disk. So as I have created a project, you can see the project here. If you look at this, edit aliases and variables, in the variables, you see that the project, the heap project is saved to that, is pointing to that like folder we're looking at. So if I file cache my timeline or a timeline that I like, it just goes there. So this could be, you can, and it goes to the geo folder. You can add some name to it, like you can say that instead of heap name, you can, heap name is this name. You can say that this is like what cache it is. It's ground base shatter cache, right? And then save to disk. So we have to wait few. So if you see that it goes through all of that. So what would happen is that your data before this is not simulative. It's not going to be calculated anymore. It's an actual physical file on your disk. So retrieval of this data is much faster. But I don't have access to the previous parts. So let me just, you can change the color of your cache files to something that like every time that you open the scene would be significant. Let's wait a little bit more. A little bit more. OK, the cache is over. So if I say that load from disk, which is checked after caching is done, even if I disconnect this, guys, I disconnected the network, but everything runs. So what happens here? I would like to build the connection, because sometimes you go back, you change things. So let me just like put all of this as into one group, base shatter. So this group is done, right? I'm done with that. So whenever you're happy with what you've got so far, and you're scared that like, oh my God, every time that I want to run through my changes, it has to recalculate every step. That's a big hassle. So you have to use cache more often, every now and then. So what you do here, so we have cached on disk. It's available. It's like very easy to work with now. So I can use debris source to source some particle Okay, so this debris source, like if you see that, like it just throws a bunch of particles on the surface, which looks cool. I don't want these inactive particles, so you can say remove unreleased, the ones that is not doing anything, remove them. I want the lifespan. So what is this debris source? Debris source is scattering some particles on the points that do change. So these points can be the source of a debris or a dust. So I would like them to be leaving less, but let me just, let's put a dust on these ones and you guys see what would happen. Let's, I don't know, I just don't build a dust from scratch, but I just search for configure let's say billowy smoke. This is some just smoke. If you look at it, let's look at this like briefly. It's a torus or just an object. Some particles are scattered around these objects as pyrosource. Some velocity is added to them, but we do have velocity already. So you see that if I middle click here, this is density P, P scale temperature. Then here, density P, P scale temperature V, which stands for velocity. We already have V here. What node was responsible for creating velocity? This trail node, compute velocity. So then it rasterizes those points, which means that it turns them into fog, solves the fog, adds some color and things on it, and just like makes a dust out of it. This is like a very thick dust. Probably not gonna working very well for us, but after some tweaking maybe. So if I just say that I already have some particles, so no, I don't use this object, and inside this pyrosource, I would say that I don't want you to scatter from volume, but keep the input, and I want you to source smoke. So what would happen is that if you see that one runs through and it just creates this very thick like kind of smoke, it must not be that thick. Dust is not that horrible. So we can do two things. One is that like make the lifespan of these very short, maybe like 3%, and also we let them die. You know, don't. So if I run this, you see that those points that are at the beginning, they don't die. They just keep emitting. They keep existing there. But I can say that, you know what, like the points that do their job, they just die. So now that the points just like die faster and okay, now I can do work on the smoke details. The first one is this particle size in voxel size and particle size, particle separation. So I'm not going to touch these because it takes time, but I leave that to you. So we have a source of like kind of a very thick dust. With a bit of massaging those numbers, you can change the color of it. You can change, let me just add some light. If you just add a skylight here, things would look prettier. Let's go back to our grand shattering. So we have this smoke here, and I can merge it with my original. So that's the debris source from the original cache. So I have this. Oh, this smoke look horrible. Let me just. I can't accept to leave it as is. So let me just work with it a little bit. Maybe we don't need to scatter that many points. Maybe we just need like not 1,000 points, maybe 30 points. Let's look at the debris source one more time. Let's play that. Yeah, that's much. Oh, still very dense. Maximum points 1,000. Oh yeah, that is a lot less points in the space. Do they help we get a more refined smoke, or like let's say dust? Just too little now. I can see eating function or not, I don't know. Let's go back to debris source, 10,000, and density scale 300. Run the simulation. Yeah, that's a better smoke. That's a better dust. You can see that it's actually look like a dust, but it still like could be better. Maybe I increase the lifespan of them to live a little bit longer. Maybe a little bit more. 300, 600. Let's go back. See, this is more acceptable than as a dust emitting from here. So once you're happy with this, like you have a cache of geometry, you can call this. So this one is called ground-based cache. Cache GO. You can cache your Pyro too, like here, file cache, this one to the disk, call this dust cache, dust cache. Run that to the disk. Then you only deal with 2 cached files. Again, you guys cache it once you're happy. So once you're not there yet, wait, be patient, work with those numbers, work with the, for example, this one is a smoke color. I should have gone and worked with the coloring of it to make it look like a proper dust rather than, smoke. But once I cache this one and I cache that one, then the continuation of my node tree would work better. Let's look at this. You see that one? We can have, let's do a, let me hide these. Oh, if I hide them, oh yeah, they still do function. Okay, so let's do one quick flip book. If you just click on this little book and run it, it gives you a nice preview. The generated preview works. You can play it like Maya Play Blast. So it gives you like some really good information about what's going wrong, what's going right. So you go back and refine on that. I already know that some parts of the ground, like here, has some artifacts. So I just didn't want to waste the time for like dealing with that. You just have to change the numbers for the orbital material fracture for that. Okay, so when you play it, I still think that the beginning, when it pops, is just too quick. The beginning. So I can add the stats going back and do this plane shape. I don't do it now. You just do it on yourself. So this one is called the base. we still have not started simulating. Let's do some simulation on it. So it was just like a very nice technique to build like a ground cracking. So how to? I actually can get this RBD material fracture out, same one. So I can copy this here with all the information on it, because we already have gone through that information. So it pasted, it uses the same polygon. How deep it was, if I just want to like build right on top of that, so I grab this distance and I move it that much up. So what I do is that I add a transform node right in the middle, and I say that move up the same amount. You see that it's exactly on top of that. Actually, I can like give it like few, like kind of just a little bit of gap as well. And then let's go cracking the surface, but I won't like to crack it like similar but somehow different. So what I do is that I press escape here, change the attributes. Let's say the seeding value here, if I change the seed value like here and seed value here and here. So it was, so seed value is just like a new, so it just changes the, it's the same sort of shattering, but like slightly different. So let's see what it does. Okay, it's shattered on top. It looks like the other one, but it's slightly different, right? So this is supposed to be like the main shattering, right? This is the main simulation. This is just is a driver, that one. So actually, I would like to tie this up, add a null here, and leave it here, and I call it out base shatter. And this is it. This is the base one. And let's create an solver on RBD. So solver, whenever you heard the word solver, it means simulation is happening. Here we have a pyro solver, which means the pyro or smoke or like liquid simulation or smoke simulation is happening. So here is supposed to move and break, but I would like this to be influenced by this collision geometry, and our collision geometry, which is underneath of it, is a deforming collision geometry. I would like to have a ground plane. If any piece has run out, I don't want them to fall into the infinity. But I would assume that in your movie, let's say, if you have such a ground, basically you don't see the edges, right? So that's, so if I lock the camera, so for example, our shot's gonna be, if I go to my camera, let's say it's a wide lens, so your shot is like looking like this. So the edges. So depending on your shot in your movie. So let's go inside. Let's unlock the camera so we don't need it. Before we start the simulation, if you remember from last session, we just do a bit of tidying up. For example, I don't want the pieces on the side to move around, and I want to be silent and sleeping until something kicks in, right? So I just search for configure RBD configure here, and I would say that select a group, maybe here and here, holding shift, and here. So this is going to be press enter while your cursor is inside the inside here, and I just say that it is active, not active, right? You can add another RBD configure here. You could do that at the same one, but I would like them differently because I can name them. So these are like inactive pieces. This one is sleeping. So you can say that it's sleeping on. So we wait until like the simulation kicks in. So let's run this through and see how it works. And then I will show you how to deal with physical properties. If you see that, like that's the underneath part. So that part will be invisible for outcome. Actually, it would be nice if I stop this. And here in the collision, I say that do not show the ground, do not show the... There's somewhere that we say that do not show the collision geometry. Oh yeah, visualize geometries. So what you see is the simulation, is not the collision geometry. So it's actually the collision geometry is kicking in and it's just throwing these stones up. So you can work. Let me just work around with some of the stuff like inside properties. There is a physical properties like bounciness. I want them bounce nice up, but a lot of friction. I would like to have some friction, so I might just say that 2 or 2.5 friction between these pieces. These are physical properties. Density, like how heavy they are, I can make them too heavy, like much heavier, like, I don't know, 3,000 units. Rotation stiffness, how much they rotate. So you can deal with all of these. So you have gravity force, but you can have like air drag or drag spinning force as well. But I leave that to you. So let's run this, see how it works first. Let's run one layer of simulation. As it runs through, let me explain. You definitely, like when you position your simulation into a context. So let's say if this is supposed to be like a ground in your forest or street, you will have more objects around it, like here and there and behind. And those objects, like they don't shatter, they don't break, but they function as like kind of a collision objects for you. So like be more refined. I think I put the bouncing is too high. Oh, that's too high. I would stop that. It's just like crazy bounce. Properties, bouncing. Maybe I just go 1. Maybe I even activate. I would like a bit of bounciness, but I would like to introduce some drag, a little bit of drag as well, and a little bit of drag spinning as well. So let's run this. So let's look at the flip book. So I just run the simulation. Still is just like too bouncy, too huge. Still is too strong. So I leave you see, but this is like a proper simulation now, like, real simulation. They're not heavy enough. Like, look at this one. So these are the things that I will pay attention to when I look at this piece. It just like is thrown away like a piece of polystyrene, not like a piece of kind of concrete. So the it looks cool, but it's wrong. So we have to work with physical properties, work with simulation, work with all the collision details to make them look like properly simulated. So how to send this back to Maya? I finished this here. If you want to, you can render it here. You can, if you can bring your camera and everything from Maya here. But also you can send this into Maya. By the way, it would be nice if we had this geometry here. The geometry, it would be to add a UV layout to it. So if we look at the UV, or I can do a UV layout. UV project, maybe from top. We project it from top. Oh yeah, that's better. So we have at least some sort of a UV map on it. So there is a UV map on it. It's projected from top. Now I can export. Oh God, I have to run the simulation again. I wish I would have cached it at least and then added some UV mapping, but that's okay. So let me go to the beginning. So I press space bar, escape, and then go to the beginning. And then here, definitely cache. But this time we cache it this way. You have to see what kind of information you want to export. Definitely do one caching first. You can call this output sim version 1, because you might want to do some other caching. And then also, so cache this first, run the cache. Actually, I can run it now. So once the caching is done, so this one cached. So what you can do, like, you have to see what kind of information you need. This one comes as, so there are the information that is with this is name, points, velocity, normal map, and there are groups as well. Also, it's packed. If you see that, it's like the number of points is just too low. So first of all, I unpack it. So I just make sure that it just like I export all the information, accurate information. So if you see that, I unpacked it and I have like this kind of like now like lots of groups, lots of information. But all I need is UV information, point information, maybe normal map, right? So I can say that at delete, attribute delete, and then I delete. What I want to delete is I delete everything except position, except normal map, except UV. Where's the UV? UV is on vertex. So maybe text. Oh yeah, UV here. So these are the ones that I don't want to delete. So if I click here, if you see that like middle click here, yeah, very tidy on here, but untidy here. So there are some groups that gets exported. Maybe you want to export them because they help you to just like assign materials in Maya. So here you just search for ROP alembic output. So that's one way of exporting. So it creates an alembic file for you. So let's save it into our project folder, into maybe I create a folder called export here, and I call it output version 1 .abc, which stands for alembic. Let's you can click here and it says like render it, which basically is creating the alembic node. The settings is up to you can specify a frame range as well, but at the moment it's just up to 50. So the alembic generation is fairly fast, and in Maya, this is how you import it. You just go to the cache, alembic cache, and import that alembic. So it should be on our project folder, which is somewhere here inside export. Soon will be there. So let's say inside export folder, that's output. So you see it's imported, and the animation, which is 50 frames, also imported inside Maya. What about the dust debris we had? That's a different type of information. So here I have the dust information. Actually, if I merge these two again together, so we want a combination of these two, right? I need to be honest, I need to run the dust one more time with the new simulation. So what I do is that I will, you see what I've done here, like cache this one and then output, use debris source. I basically reconnect this here and let that run through one more time. So I get like dust from, well, I can do both. I can get dust from the ground, the underlying layer, and also each one of these pieces. That's the right way. So not sure if I do it now because it takes time. But what I can say that how you can export the dust after, let's say, you run that. So you export it with, so first of all, you need to convert to VDB. So what is VDB? If you search for open VDB, that's a set of programs that has enabled, so it's an open source created by lots and lots of people in the industry, especially Rob Bredo, head of ILM. He's a lovely man. So they worked together and they created a platform to exchange volumetric data between platforms. So you just can feed your volumetric data here. You can say that it is VDB, and let's convert to fog or no. I think no change is fine. And then you export that as file cache again, like a file cache. But this file cache needs to be slightly different. I would go to my export folder. here and I name it, actually I can name it this way. I can name it dust.vdb. That's it. That's actually, it requires a padding. Let me and the password needs to be VDB, so it doesn't need this. It needs to be dust and then VDB. But I'm not sure if it requires a $f, but we can see that. We can, because if it let's leave that $f, so it generates like 1 VDB for one single frame, every frame. So let's save that to disk. It's pretty fast. It actually just happened right away, because we already cached it before. It's good to name it that as well, VDB out. So in Maya, you can import it with here, Arnold volume. So it's added right in the middle. You say Control A to go to the, so let me hide the shattering. So here you point to your VDB, which is inside this project export folder. Okay. I should have, let me just go back. I should export it one more time in a different way instead of no versioning needed. Also, just dust and export it again. So I think we just need one file. Oh yeah. So you just need 10 of this versioning and do not need a $f. That's another thing. So it just exports it into a folder, a sequence of VDBs. So you just load that one, make that it's an image sequence. Well, it's a file sequence, and the density is what you're looking for. So and it's a volume. So you see that. So you might not be able to see it because there's no shader on it. So what you can do, you can go to Hypershade in Arnold, make a shader for volume, which is called AI standard volume. So, and you just drop it, assign it to this. So this assign material, and let's just add some Arnold light and see how it works. So you see that it's there, but it's black. So you just have to start working with this colors and samples. Like, let's say, good to have like 5 samples to get it like better. Intensity higher. Oh no. That's the light intensity I'm touching. Oh, what I'm doing, I'm just working with the light. Sorry, my bad. Let's go back to our material here. So it's work on the density and the color. So you can see that I can change the color to something else. I don't know. I just change it to red so you can see it better. So that's how you bring the VDB back to my. So let's review before we finish off. You can generate, so this one is basically here is pyrosourcing, is the source for the smoke. This one here is the like real simulation, the RBD simulation, and you can send off all of that into back to Maya, but also you can render, bring Maya camera and light here and render them here, so you can combine them together. Cool.